This is a review discussion about solutions. Let's focus about the different concentration units. Again, concentration, this refers to the amount of solute per given amount of solvent or the solution. Let's start with percent by mass. Percent by mass, this is also referred to as the weight concentration. This is expressed as percent weight per weight. And let's consider this one. We have 30 grams of HCl in 70 grams of water. Let's start with the formula. Again, the formula for percent by mass is equal to the mass of the mass of the solute over the mass of the solution, the mass of the solution. So first, it's important to identify which one is the solute and then the solvent. Again, the solute is the one being dissolved in the solution. Meanwhile, the solvent, this is commonly the one in greater amount. It's commonly the one in greater amount. So for example, so over here we have 70 grams of water. So this one is the solvent. Meanwhile, this one, HCl, this one is the solute. Okay, the solid HCl, then this is the solvent. And again, ang tawag sa solute and the solvent, they make up the solution. So they make up the solution. So again here, we need to identify the mass of the solute. Again here, the solute is the HCl, and here the mass of HCl is 30 grams. So let's put it over here over the mass of the solution. Again, the solution is equal to the mass, or it's equal to the solute and then the solvent. So here, for the mass of the solution, just add the mass of the solute and then the mass of the solvent. We have 30 plus 70. We have 100 grams. And this is percent. So pag percent, always multiply by 100. And then if you solve this one, we have 30%. So this is the weight concentration, or the percent by mass of the solution. Let's proceed to percent by volume. Percent by volume is also referred to as the volume concentration. This is expressed as percent volume per volume. Let's consider this one, 50 ml of sulfuric acid with 50 ml of water. So again, the formula for this, we have percent volume per volume is equal to the volume of the solute, over the volume of the solution, Again, it's important to identify which one is the solute and which one is the solvent. So here it's the sulfuric acid, then this one is the solvent. So as we all know, water is the universal solvent. So pag merong water, it's in most cases that's the solvent. And then here, this one is the solute. So this solute again is mixed, or it's dissolved in water. So again, we need the volume of the solute. Here, this is the solute, and the volume, this one is the volume. So we have 50 ml, 50 ml of the solute over the volume of the solution. Again, this is not the solution, this is just the solvent. Again, the solution is made up of the solute and then the solvent. So that's 50 ml plus 50 ml. We have 100 ml times 100. So if we solve this one, we have 50%. Okay, that's the percent by volume of the solution. Now let's consider the following problem. How many grams of HCl is present in 100 grams of 10% weight per weight hydrochloric acid? So here, given na yung percent by mass, again, pag weight per weight, that's the percent by mass. We also have here the mass of the solution, but here we're asked to determine the mass of the HCl. So first, this one is the solute, the HCl. This is again mixed with some solvent, so let's assume that the solvent here is water. Again here, the HCl is dissolved in water. Then again, the overall mass of the solution is 100 grams. And let's say this is, the percent by mass of the solution is 10%. Okay, 10%. Okay, from this, let's answer this one. So let's start with the given. Again, for the given, look for the numbers and then identify what does this number mean from the problem. We have here 100 grams. 100 grams. What is this 100 grams? This one is the mass, right? Again, per grams, that's obviously the mass. The mass of what? The mass of this is the solution, the hydrochloric acid. So this is the solution, the mass of the solution. How about this 10%? This one is the percent by mass of the solution. The percent by mass, or the weight concentration, is equal to 10%. Again, here we're asked to determine the mass of the HCl. And again, over here, the HCl is the solute. So we're asked to determine the mass of the solute. Okay, for this case, let's let X be the mass of the solute. Let's proceed with the solution. So for the solution, we can use the percent by mass formula. Again, the percent by mass is equal to the mass of the mass of the solute over the mass of the solution. The mass of the solution. The percent by mass is equal to 10%. So to make it easier, let's convert this one into its decimal form. This is equal to 0.10 is equal to the mass of the solute. Again, we are finding for this one, so we'll use X for now. Then the mass of the solution is also given 100 grams. Now we're looking for the value of X here. So what should we do? We can do cross multiplication. That's over 1. Again, this is a whole number, and every whole number has a denominator of 1. Now let's cross multiply. 1 times X is X. Then 0.10 times this one. 0.10 times 100 grams. Then if you solve this one, 0.10 times 100, 0.10 times 100, we have 10. Okay, 10 grams. Okay, so the mass of the HCl here is equal to 10 grams. Let's proceed to the next item. How many ml of HCl must be added to 50 ml of water to make a 20% volume per volume hydrochloric acid? Again, always start with the given. We have here, this one is the 50 ml of water. This is the solvent. Again, 50 ml. Again, pag water, that's the solvent. Ml, that's the volume. Volume of the solvent. We have 20% volume per volume. That's the percent by volume of the solution. 20%. And here, we're asked to determine the volume ml of the hydrochloric acid. Again, this one is the solute on this problem. Again, the volume of the solute. Okay, for now, let X be the volume of the solute. Now we're ready to solve for this one. We can use the percent by volume formula. It's equal to the volume of the solute over the volume of the solution. The percent by volume is given. We have 20%. Let's convert this one to decimal. It's equal to 0.20. It's equal to the volume of the solute. Again, here we are finding for the volume, and here we'll use the variable x for that. The next, the volume of the solution. So again, it's also not given because this one is the solvent. It's not the solution. Again, the volume of the solution is obviously it's equal to the volume of the solvent, right? That's the volume of the solvent plus the volume of the solute. In this case, the volume of the solvent, wait, let's try to arrange this one. The volume of the solute and then is equal to plus the volume of the solvent. Here again, the volume of the solute is X. We don't know the volume of the solute yet, but we know the volume of the solvent is equal to 50 ml. Again, this is the volume of the solution. So for the volume of the solution, we can use this expression. We have X plus 50. X plus 50. Next, we're looking for the value of X here. What should we do? We can do cross multiplication. 1 times X is equal to 0.20 times X plus 50. X plus 50, X is equal to 0.20 times X is 0.20X plus 0.20 times 50. 0.20. 0.20 times 50. We have 10. Okay. 10. Then after that, what should we do? We are looking for the value of X. So we can transpose this one to the other side. That is equal to X. Then that's positive 0.20x. If we transpose this one to the other side, this becomes negative 20. Negative 0.20x is equal to, what's left on the other side is 10. Now x minus 0.20x. This one is there's no number here. It means there's 1 here, right? That's 1x minus 0.20x. That's 1 minus 0.20. 1 minus 1 minus 1 minus 0.20. We have 0.8. So 0.8 x is equal to 10. Then again, looking for the value of x, we can divide both sides by x. By x, by 0.8. By 0.8. 0.8, 0.8. Then divide 10 divided by 0.8. 10 divided by 0.8, we have 12.5. So here, x is equal to 12.5. This one, by the way, is ml. Okay, so that's the answer for this item. Next, let's go with the concentration based on the number of moles. So we have the mole fraction, molarity, and molality. The mole fraction, we have x. It can either be the mole fraction of the solute or the mole fraction of the solvent. So here we'll use x to represent the mole fraction, then A for the solute, B for the solvent. Again, the mole fraction of the solute is equal to the number of moles of the solute over the number of moles of the total solution. Meanwhile, for the mole fraction of the solvent, it's equal to the number of moles of the solvent over the number of moles of the total solution. Now for molarity, it's equal to the number of moles of the solute over the volume of the solution in liters. Again, this is the moles of the solute. Then this one is the volume of the solution in liters. Okay, that's moles per liter. Then for the molality, is equal to the number of moles of the solute over the mass of the solvent in kilograms. Again, that's the number of moles of the solute and then the mass of the solvent. Okay, it's not the solution. So these are the concentration units based on the number of moles. So for this one is we need to, of course, in most cases, given yung mass, right? Then again, pag mass, you always convert that one to its equivalent number of moles. And for this one, we have learned this one in Chemistry 1 about mass to mole conversion. Let's answer this one. Commercial vinegar is essentially a solution of acetic acid in water. Again, here the solution is the vinegar. So vinegar is a solution. So it's made up of two or more substances. On this case, it's mostly made up of acetic acid in water. So here, this is the solute. Then obviously the water is the solvent. Here, a bottle of vinegar has 3.78 grams of acetic acid per 100 ml of the solution. Assume that the density of the solution is 1.00 grams per ml, given that the molar mass of acetic acid is 60.0.5 grams per mole. Let's determine its molarity. Again, molarity is equal to the number of moles of the solute over the volume of the solution in liters. Let's start with the number of moles of the solute. So here again, the solute is the acetic acid, and again we need then here the given is the mass of the acetic acid. Again here we need to determine the number of moles, and we can do that by doing a mass to mole conversion. So here again the mass is equal to 3.78 grams of acetic acid. Let's convert this one to its equivalent number of moles. Again, that's from grams to moles. So here, 1 mole is equal to 60.05. So it's already given yung molar mass ng acetic acid, 60.05 grams. Then we can solve this one, 3.78 times 1 divided by 60.05. 3.78 divided by 60.05. So this is 0.0629. 0.0629 moles. Okay, 0.0629 moles. That's the number of moles of the acetic acid. Again, we get this number by doing a mass to mole conversion. And of course, for the mass to mole conversion, we need the molar mass of the substance. So here it's already given yung molar mass. Next, we need the volume of the solution in liters. So here again, the solution, ang given is yung, okay, that's the volume, right? 100 ml of the solution. But again here, the volume must be in liters, okay? So to convert this one to liters, again, that's 100 ml, 100.0 ml. To convert this one to liters, we can just move the decimal places 3 places to the left. That's 1, 2, 3. So we have this one, 0.1, okay? 0.100 liters. After this, we have the number of moles over the volume in liters. Now we can solve for the molarity of the solution. That's 0.0629, 0.0629 divided by 0.100 is equal to 0.629. 0.629 moles per liter, or again we have a unit for moles. I mean for this one we have 0.629 molar. So we use the capital letter M. Again, this one is read as molar. This is the unit for molarity.